Okay, so this is problem 3 from homework 3. And so we're asked to draw a graph of a function which has all of these 5 properties, or explain why it's not possible to draw such a graph. So first, let's think about what all these properties are telling us, then see if we can draw a graph that has all these qualities. So this one here, f of x greater than 0, just means the function is positive. Or in other words, it should always be above the x-axis when we draw our graph. F prime of x greater than 0 means that f is increasing. So our graph should always be going upwards. This says that f is concave up over the interval from negative infinity up to 1. If the second derivative is 0, that means that our function should be a linear function. Right, because if we think about something like ax plus b, that has no second derivative, because when we take the first derivative, we just get the slope of the line, which is a constant, so when we take the second derivative, it's 0. So anytime you see something with second derivative equal to 0, that means that it has to be linear on that region. And then lastly, we have f double prime of x less than 0, so that means the function is concave down in that region. So let's now try to draw this graph. So first of all, since f always has to be positive, but f is also always increasing, we know that we're going to have some sort of horizontal asymptote on the left-hand side, because otherwise, if f were to keep going downward as we move to the left, then it would eventually cross the x-axis. So, downward at a constant rate, I mean. So it has to somehow level off and have a horizontal asymptote. So let's do something like this. And then we know that it's concave up for x less than 1, so let's draw it sort of curving upwards. And let's say that 1 is here. So this is how our function looks for x less than 0. Now, between 1 and 2, or sorry, for x less than 1, between 1 and 2, the function should be linear, but also we want this function to be differentiable. So that means when we draw this continuing as a line, we can't have a sharp corner or a cusp at this point, so we have to try to draw it so that it sort of continues with the same slope that it had up until it reaches 2. And then from 2 onwards, it should be concave down. So again, we want to draw it continuing with the same slope, but then curving downwards like this. So we can see that this meets all the properties. It's always positive, always increasing. It's concave up here. It has 0 second derivative here, and it's concave down here.